Okay, everybody, here's your homework help video. So we're using trigonometric identities. Number 1, write the expression in terms of sine and cosine, and then simplify so that no quotients appear in the final expression. We have cotangent theta times sine theta. So let's change cotangent theta and write it as cosine theta over sine theta. And that is being multiplied by sine theta. So notice that we have a sine theta on the top and the bottom, so we can cancel those. And all we have left is cosine theta. So there is our simplified expression. Number 1b, same directions. This time we have cosine theta times cosecant theta. And so what we can do is rewrite cosecant theta in terms of sine. Cosecant theta is 1 over sine theta. So we have our cosine theta times 1 over sine theta. This time nothing cancels. We can combine it into one fraction, cosine theta over sine theta. But the directions say no quotients should appear in the final answer. So changing to sines and cosines, that was a temporary step. It doesn't mean they have to end up being in sines and cosines. It just helps us sometimes to transition from one thing to another. So what can we replace this quotient with? Notice that cosine theta over sine theta is equal to cotangent theta. So we'll replace that quotient with cotangent theta, and now we have something that's simpler and it doesn't have a quotient. So that's our answer. Number 2. So this time I'm advising that you may or may not find it useful to convert to sines and cosines, or you might just not do it in the beginning and you might do it later. And often that's the case when you have something that looks like a Pythagorean identity. If it has trig functions squared in it, you can start by looking at your Pythagorean identities and maybe do some kind of substitution. So 1 plus tangent squared theta is equivalent to secant squared theta. So let's start there. So we have cotangent squared theta times secant squared theta. So that looks simpler already. Now would be a good time to change to sines and cosines. So cotangent squared theta, let's use this one and square the top and square the bottom, and we would get cosine squared theta over sine squared theta. And for secant squared theta, we're going to use this one, secant theta equals 1 over cosine theta, and just square it, and then we get 1 over cosine squared theta. So notice that we have a cosine squared theta on the top and the bottom, so we can cancel that, and what we're left with is 1 over sine squared theta. So things got simpler, but now we have a quotient, and we're not supposed to have a quotient in our answer. So remember that 1 over sine theta is equivalent to cosecant theta. So if we square it, it will be equivalent to cosecant squared theta. And that is our simplified expression. Number 3. Same directions. You may or may not choose at some point to change to sines and cosines in the process of trying to simplify. And our goal eventually is to not have any quotients. So once again, let's take a look at our Pythagorean identities. So we have 1 plus tangent squared theta. We can replace that with secant squared theta. And then for the denominator, 1 plus cotangent squared theta, we can replace that with cosecant squared theta. So that looks simpler, but perhaps there's more we can do. So now let's go ahead and look back at our reciprocal identities to change to sines and cosines. We can replace secant with 1 over cosine. So we can replace secant squared theta with 1 over cosine squared theta. And we can replace cosecant with 1 over sine, so we can replace cosecant squared theta with 1 over sine squared theta. Now we have a quotient of fractions, a fraction divided by a fraction. So let's change it to the top fraction multiplied by the reciprocal of the bottom fraction. So that gives us sine squared theta over cosine squared theta. Now we know that sine theta over cosine theta is tan theta, so if we square that, we get tan squared theta. So that's definitely a simplified expression. It's not a quotient. It doesn't have sines and cosines anymore, but that's okay. We weren't told we had to end with them. We just sometimes use them temporarily in the middle. Okay, let's take a look at 3b. Well, notice that we have sine squared theta plus cosine squared theta, and sine squared theta plus cosine squared theta, that is our most popular Pythagorean identity. That is equal to 1. So replace that with a 1, and we still have the plus tangent squared theta that we haven't addressed yet. That was from the middle of the problem. But take a look at this. 1 plus tangent squared theta, 1 plus tangent squared theta. It's equal to secant squared theta. Bada boom, bada bing. Simplified and not a quotient. There we go. Next one, number 4. All right, so what we did when we did the example in our notes was we started by distributing. So I'm going to multiply cosine theta and secant theta. And then I'm going to multiply cosine theta and cosecant theta. Okay, now how can we simplify each of these? Remember that secant and cosine are reciprocals. When you multiply reciprocals, you get 1. That's one way to think of it. Another way to think of it is to replace secant theta with 1 over cosine theta. And you'll notice that you can cancel the cosine thetas from the top and the bottom. And then for the other one, let's replace cosecant theta with 1 over sine theta. So our first term is just 1. And then here we have, for our second term, we have cosine theta over sine theta. But that's a quotient, and we've been told in the past, try not to leave a quotient. It doesn't say exactly that here, but if we're going to try to not leave a quotient, we should replace cosine theta over sine theta with cotangent theta. So we have 1 plus cotangent theta as our simplified expression. Last one, I think, number 5. Okay, the one we had in our notes, we had to square a quantity. Just like here, we have to square a quantity. And remember, when you're squaring a quantity, you end up using the FOIL method. You can't just square the individual parts. The order of operations doesn't work that way. Okay, so when we FOIL this, multiply the first and we get 1. Multiply the outsides and we get sine of t. Multiply the insides and we get sine of t. And multiply the last and we get sine squared t. And at the end, we still have plus cosine squared t. Well, would you look at what we have here? Sine squared theta plus cosine squared theta is 1. So sine squared t plus cosine squared t is 1. All right, so we have the 1 from the beginning of the problem as well. And we have the 1 that we just found. 1 plus 1, can you tell me? I know we're getting rusty. We haven't had a lot of school, but yep, you got it. It's 2. And then let's also go ahead and add together these 2 sine t terms, and that would be 2 sine t. So we have 2 plus 2 sine t. And that's our simplified expression. I think that takes us to the end of the homework. So all that's left is this. Thanks, everybody.